All right, guys, today we are doing point slope form. It's one more form of a line. We've got slope intercept form, standard form, and now point slope form, and it will be the last one. And we're on page 34, which is the left-hand side when you open up the notebook side by side. All right, again, the title of the notes today is point slope form, and you should be doing this on December 10th or 11th. And again, we're on page 34, which is the left-hand side. You can see that my spiral is in the middle there. So the learning target is that I can use and write point slope form from various representations. Okay? So firstly, what is point slope form? As I mentioned before, it's another way to write a function rule, and function rule is just another way to say equation of a function, right? Specifically for a function. And of a line. So specifically the function that's a line. We've been dealing with only lines because everything has been linear, using the slope and any point, which is nice because before we had to use exactly that special point called the y-intercept. So what we want to do is first determine where does it come from, and then what is the form. So it comes from the slope formula. So hopefully you have this memorized, but the slope formula from day one notes is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you might be wondering, why did I put those in parentheses? I added parentheses because what we're going to do is actually multiply both sides of the equation by the denominator. So I'm going to take the denominator here and multiply this side by the whole denominator in parentheses, right? Because it's like a package deal. Think about parentheses like a package. But you got to do it to both sides. So I'm also going to multiply this side. I didn't really leave myself room, did I? X sub 2 minus x sub 1. Okay. And what I'm doing here is rearranging this equation. It's gonna contain all the same parts. I'm just moving them around. So what happens is I multiply by the denominator, but that would be once in the numerator, once in the denominator, those divide out. Those are gone. So the only thing left here is the numerator, which is y sub 2 minus y sub 1 equals, and then here I have these times each other, and hopefully you know that when you multiply, you can write them in either order, right? 3 times 2 is the same as 2 times 3. So I'm going to write m first, and then x sub 2 minus x sub 1. Okay, so I just flipped those. That's what's happened. And then, in addition to that, you can also flip-flop things on either side of the equal sign. So all I'm going to do is essentially crisscross these two sides. So this whole side is going to come to the left. So y sub 2 minus y sub 1 equals, and then this whole side is going to come over here, m parentheses x sub 2 minus x sub 1. Okay, so again, I put them in parentheses because it's a package. Now, if you read the definition again, it is the slope and any point, but it's only one point. Here we have two, right? That's why we have these subscripts. The 2's are from a second point. Well, we don't need a second point. You only need 1 point. So I'm going to get rid of this because we only need 1 point, right? So all I'm doing is getting rid of the subscripts. The x and the y are still there. So what that does is it makes us have the slope and 1 point. So this is actually the form right here. Parentheses y minus y sub 1. So there's no longer a y sub 2. Because remember, when we write our equation, we always have an x and a y in it. So I need something that's not going to be a number. So that y will always be a y. Equals, and then m parentheses x, again I dropped the sub 2, minus x sub 1. And there you go. That's it. If you have a highlighter, I would highlight this. And again, you can always solve for it if you want. Personally, I prefer to memorize it, but that's just me. You do have to memorize it though if you're going to do that. So just a few things real quick. This guy here, this is the slope. Okay, then we have our x sub 1 and our y sub 1. These are a point, any point, doesn't matter. That's where they come from, but it's the ones with the sub 1s, because lastly, these guys here, the y and this x, we leave as x and y. Okay? So, there you go, kind of like we did before where we pointed out the y-intercept and the slope, and we leave the x and the y alone. This is the new form. I really like this form because we had to do a lot of solving to get that y equals mx plus b. Like finding b sometimes can be hard. Here, we can use any point. Okay? Pretty slick. So, now what we want to do is how do we find this from various representations? Now we want to talk about how to find it. So we find it in various different ways, like we've been doing. There's from a graph, from a table, and from 2 points. So what we're going to start with is from a graph. So if you're finding it from a graph, then the graph should already be given to you. So here, this is just scaled by ones. I skewed the drawing a little bit because it's mostly in quadrant 4, so I thought that would be a better picture. So again, scaled by 1, so that point is over 6, 1, 2, 3, 4, 5, 6, and down 2. And just for your drawing needs, this is at -4 here, but I'm actually going to use that point. So the first thing we need to do is find the slope. So the slope, find the slope, I'm actually going to find it up here. So if you recall, slope for a graph is m equals rise over run. So I need to find rise over run. So if I can use anything I want, then I'm going to use 2 nice points. So I already have this point, and it looks like this point right here is very nice. I don't even care what that point is. I care about how do I get from one point to the next. So it looks like I'm going to go up and over, and that up, since I'm scaled by ones, is just +1, and that over is 1, 2, 3, because I'm just scaled by that. So my rise over run ends up being +1 over +3, which is just 1/3. So there is my slope, 1/3. Okay? And since the point is rising from left to right, it makes sense that that would be positive. Then notice it says pick any point. And now I know I say any point. It needs to be on the line, guys. It needs to be something. You can't pick like the origin because it's not on the line. So since we're given this point, let's just use the point 6, 2. 6, -2. Oof, that would have been a bad thing. Okay? So now I have my slope and my point. From here, I plug it into point slope form and just simplify. So you know me, I like to first just copy down what is point slope form, which is y minus y sub 1 equals m parentheses x minus x sub 1. Now, this is like the slope formula because we got it from the slope formula, remember, that that means that these negatives are built in. So something I like to do is I will literally copy everything but leave spaces for y sub 1, m, and x sub 1. So what I mean is y minus blank equals, m, I don't know what m is, blank, x minus blank. And so that way I know I have my minus signs in because they are built into the problem. Okay, so up here, this is my x sub 1, y sub 1 from the point. You just want to make sure that you don't go, oh, this is on the left, so it goes here. No, this is y minus, so make sure you use the y value, which is a negative 2. And I'm going to put that in parentheses because it's negative, so it's minus a negative. And then this x minus, that goes with the x value, which is just 6. So I don't need to use parentheses because it's just 6. Okay, then I have my slope up here, which is my m value, and that goes in front of the parentheses. Now, the last thing to do is to simplify. So just like in the slope formula, these can be, double negatives can be changed into addition. Okay, so that means I have y plus 2. I'm also going to drop these parentheses because if there's nothing in front of it, then the parentheses don't actually represent anything. Equals, and then 1/3. And you have to keep these parentheses because remember it means 1/3 times this whole package deal here. So I can't drop those. And that is your point slope equation. Okay? So there you go. So this changed to plus only because it was minus a negative. All right, now let's look at from a table. So from this table, again, the first step is to find the slope. So, excuse me, how do we find slope from a table? That is change in the dependent variable over change in the independent variable. Okay, if you are not slick with these ways yet, you might need to go back and finish the class kick from day 1. Okay, so the dependent variable is on the y side, and what is happening over here? Well, it looks like we are adding 6 every time. So the dependent variable is, the change in it is plus 6. Then over here, we have plus 2 on the independent variable side. So see, don't just do 6 divided by 3, that's not correct, right? We need to actually use the change, which is positive 2. And positive 6 divided by positive 2 is positive 3. So what is the slope? It is 3. Okay, then it says pick any point. Again, you can do whichever one you want. So instead of just picking the first one, why don't we pick the second one? Again, things that you might try and avoid, negatives, fractions, decimals, but again, it doesn't matter because you can use any one you want. And so I'm using 5/12. Then my last step is to plug it into the form and simplify. So again, I'm just going to start by writing the equation as is. Y minus y sub 1 equals m parentheses x minus x sub 1. Okay, and again, I'm going to leave blanks for the things I'm going to plug in. So I have y minus blank equals blank times, so parentheses x minus blank. So again, I'm ensuring that I'm getting those minus signs in, and then here those end up both being positive, so that's nice. And then this is x sub 1, y sub 1. So remember, y goes with the y minus, so that's 12. And then here, x value goes with the x minus, that's 5. And then my slope is 3. Okay, and actually that's good right there. You can rewrite it. I'm going to rewrite it just so I don't have all these different colors and lines, but these parentheses are not being used, so I'm going to drop them. But if you left them in the answer, I wouldn't be mad. So y minus 12 equals 3, parentheses x minus 5. You have to keep those parentheses. And there is your slope, point slope form. Okay, and the last one is from 2 points. Okay, so again, this was the one that I'm always like, it's the most intensive, but if you have your calculator, then of course you are allowed to use that, because for this one we need to use the slope formula. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to go ahead and label these up here. So I'm just going to make this the first point. I don't see any benefit in switching them at this time. So x sub 1, y sub 1, x sub 2, y sub 2. Okay, so now that they're labeled, you can, what I call, hunt and replace. So you hunt for the number and then put it in, but remember those minus signs are actually part of it. So again, you can kind of use my strategy from before where you kind of leave blanks in here. And my y sub 2 is -4. And my y sub 1 is -2. Now the second one I'm going to put in parentheses because it's minus a negative. Okay? Then my x sub 2 is 15, and my my x sub 1 is 10. Equals, and then remember this becomes plus. So we get -4 plus 2 over 15 minus 10, which becomes -2 over 5. Now that is actually already simplified, but you can get around that by using your calculator. So I had to go grab my calculator, but see here where we have this entered in? You can actually do that all from your calculator since you know fractions. So firstly, we want to get to fractions by doing alpha and then y equals. And then remember this pops up. And again, this is the same calculator you guys have on your Chromebooks. And I'm going to do n/d because I don't want a mixed number, I just want that. So now you have this. You can actually do the math right in there. Make sure though when you do a negative, you click this negative way down at the bottom, and when you do a minus, you click the minus that's off to the right. So we have -4 minus, and then the parentheses are above the 8 and 9, so parentheses -2. And then I use the down arrow to get down, and then 15 minus 10. Again, I used the minus sign for that over here. And then you hit enter, ta-da, -2/5. So it will do it for you. I want to see this on a test. You need to plug it in for me. I want to see that step, but then you can go straight to the answer. And I'll assume to use a calculator. Okay, but I do need to see the setup. I like seeing this too, but again, I need to see that you put all the numbers in the right place, etc. So notice that the negative is out front for that because you can put the negative anywhere, just don't double up on the negative. And there you have your slope. Then it says pick any point. It does not matter which point you pick, so I'm just going to pick the one that already has an x1 and a y1. Sure, why not? So this is 10, -2. Okay, so again, that's x1, y1. Okay, you can pick this one. You will still get it correct, just so you know. And all of these, if you pick a different point, that's fine. Just make sure that you simplify and plug in correctly. Okay, so again, I'm going to start with my form. Y minus y sub 1 equals m parentheses x minus x sub 1. And again, I'm going to rewrite it, leaving blanks for my spots that I'm going to plug things in so that I know I have the negatives in the correct spots. So the slope is -2/5. I kind of drew my little line lower because I knew it was a fraction. So -2/5, and then my point values for y, make sure you use the y, and since it's negative, I'm going to do parentheses around the -2. And then here, for my x value, it is 10. So, then what I'm going to do is remember, simplify, so this minus a negative becomes y plus 2. You don't need the parentheses on that side because there actually is nothing in front of it. Okay, and I mean truly nothing. A minus sign would even be something. Okay, equals, and then -2/5. And then here there's nothing to simplify, so parentheses x minus 10. Okay, so I mean, for slope-intercept form, you always have to find the slope anyway. So here I love that you can just pick any point that is on the line or given to you and put it right in. Next, we're going to go over some different ways to use point-slope form if you already have it. All right, so the last thing is using point slope form. Now I have two sections here. We're going to start with the graphing from point slope form. But I want to give you a heads up. Both of these are kind of twofers. They're built in with two ideas each. So yes, we'll be doing something that the title says, but there's also kind of a hidden thing that you definitely will want to know. So we're going to start here with graphing. Let me zoom in. Okay. So graphing from point slope form. So here's the equation, and I drew a little graph, and I'm running out of room, so it's pretty small. Remember that you can always like tape in an extension or do like a sticky note and then fold it up when you're done, because I guess I'm determined to make this one page. So the first thing it says is make it exactly point slope form. So what that means, remember, point slope form is in the form of y minus y sub 1 equals m parentheses x minus x sub 1. So here, this is fine. It's in the form of minus y sub 1, but this has a plus sign, and that is not part of the form. So we need to rewrite this to be y minus 3, that's fine. The slope is obviously negative 2/3. Okay, and then, oops, I forgot this parenthesis. And then I need it to be x minus. So since I need it to be x minus, well, how did it become plus in the first place? Well, it became plus because there must have been a double negative. So this should really be negative 4. And that's how we got that plus sign. So I'm just making sure that we undo that, because now I have to identify the point. And if you say that's a positive 4 and that's a negative 3, you're wrong. Okay, so this is kind of the hidden message in this one, is you need to make sure to undo that plus sign. Think about taking the two lines from the plus signs and splitting them and making two negatives minus a negative. So then from here, all we're doing is identifying. So m is in this spot here, so slope is negative 2/3. And then identify the point. Well, the point, it says make sure to go after the minus, don't include it, because remember, minus is built into it. So we go after the negative, or the minus, I'm sorry, and make sure you put them in the right place, because this one's with the y, this is the y value. So the y value is 3. And then over here, x minus, and you go after that. And again, since that's with the x value, or the x, it's the x value, is negative 4. Okay, then from here, it says to plot the point. So plot the point negative 4, 3. So this is just scaled by 1, so I don't have to actually write in the scale. So I go back, and I know this is going to be messy. So 1, 2, 3, 4, and then up 3. 1, 2, oh boy, that was close. There is my point, negative 4, 3. Okay? And then the slope tells you how to move. So it's exactly the same as when you plot the y-intercept and use the slope, except your slope is going to start at this point here. So remember that slope for a graph is rise over run, and in this case there's a negative. Remember, you can put the negative anywhere you want. I like to move it to the numerator, so it's negative 2 over 3. Just don't double up on the negative. So that tells me to go down 2, right 3. Okay, so from this point, I'm going to go down 2, right 1, 2, 3, down 2, right 3, minus 2 plus 3, down 2, right 3, boom. And then I'm going to use a ruler to make my line, and you add arrows. Oh wait, don't be lazy. Add the arrows. The line technically goes on forever. So if you ignore all that stuff, there's your beautiful line. Okay, so that's the steps. So again, the hidden thing in this is really important, super important. You're going to use it for different things. If it asks you to identify the point, make sure that you switch it back into the original form, like undo the simplification. Those pluses become minus negatives again. Okay, and that negative 4 is your x value. Okay, Now the last thing, again, this one will have a hidden message in it as well, and that is from, sorry, just making sure my thingamabob doesn't tilt over. There we go. So we are converting to slope-intercept form. So yes, making point-slope form can be easier, but sometimes we just want it in slope-intercept form. Well, you can actually take slope-intercept point-slope form and convert it. So here's what we do. I'm going to do a little refresher from right above where we start with 2 points because, again, I'm going to make a second point here, like a hidden message, and that is to find the slope. So we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then again, I'm going to make the first point be x1, y1, and then the second point be x2, y2, because there's no real benefit. It actually is nicer with the negatives coming second. And you'll see why. Because then we do hunt and replace. So we have -1 as my y2 and -5. So I'm going to put that in parentheses because it comes after the minus. And then x sub 2 is 8 minus, and then my x sub 1 is -24. So it's nice that these came second because now I have minus a negative and minus a negative, which turn into plus a positive. So now I have -1 plus 5 over 8 plus 24. So that makes positive 4 over positive 32, and if you know, that simplifies to 1/8. So again, I am going to point out that you can, straight from here, once you've written this in, you can replace or do this in your calculator. So you do alpha y equals, and then choose the first one, and then you just enter it in. Make sure that you use the negative symbol for negative, so -1 minus, and then parentheses -5, and then arrow down, and then 8 minus, parentheses -24. Okay? Enter. It already just tells you 1/8. So if you start here and end here and skip these steps, that's fine, but you again need to write this. Don't know why people don't watch the video. I tell you exactly what I'm looking for, guys. Come on. Come on. So then it says pick a point, and you'll notice that I actually did a dashed line and did both of the points. So this is where the hidden message is going to come in. Okay, so remember I told you can pick any point. So again, I'm going to kind of stretch this here because I'm running out of room. I'm not actually going to write the original form down. I'm going to go straight to plugging it in. So I have y minus blank equals blank, parentheses, x minus blank. So I'm going to start with this one. My y value is -5. My x value is -24. Boop. And my slope is 1/8. Okay, then I'm going to simplify this so that it is y plus 5 equals 1/8, parentheses x plus 24. Okay, so just like we did above. Now I'm going to do that same thing over here. So again, I gotta skip the writing the form out just because I don't have enough room. Y minus blank equals blank, parentheses, x minus blank. Okay, so again, the slope is still 1/8. But this time, the y value is -1, and the x value is 8. So then, if I rewrite that, I will get y plus 1 equals 1/8, parentheses x minus 8. So in this one, that one stayed minus because it wasn't minus a negative. Okay, so now I have 2 point slope forms. Great. But I want to convert it to slope-intercept form. And slope-intercept form is y equals. Okay, y equals mx plus b. Y equals. So the first thing that we need to do is distribute. Okay, so hopefully you remember how to distribute. Okay, and what that means is you take the thing outside the parentheses and multiply both things inside the parentheses. So here, we have to do 1/8 times x and 1/8 times 24. So notice that this side's not going to change at all because there's nothing to distribute over here. So we still have y plus 5 equals, and the easy part is 1/8 times x is just 1/8 x. Okay, but then you have to say, okay, well, what's 1/8 of 24? I know that that's 3, but if you don't know, again, on your calculator, alpha y equals, enter, you can do 1/8 times 24. Enter. Oops. Sorry, and you get 3, so you know that's a positive 3. Now I'm going to do the same thing on this side, so I'm kind of solving both of these simultaneously. So over here, again, I'm distributing on the right-hand side. There's nothing to do on the left-hand side, so y plus 1 stays the same. And again, 1/8 times x is just 1/8 x. That's the easy part. But then we have 1/8 times -8. I know what that is, but we can use our calculator. So we do alpha y equals, enter. And I'm going to do 1/8. And this time I'm timesing it by -8 because there's a minus sign here. Okay? And that gives us -1. So we're going to write -1. Okay. Great. Now, the last step is that, remember, it's y equals, meaning the y needs to be all by itself. So what are we going to do? Well, get that thing away from y. So get y alone. And we do that by doing the opposite. So here, it's plus 5. We're going to subtract 5. Okay? Boom. That gets my y alone. But you have to do the same thing to both sides of an equal sign. Now, it gets confusing if you try and do it with the x, but remember, those aren't like terms. So line it up with the other number, plus 3 minus 5. Done. So the 1/8 x, nothing changes. Just leave it 1/8 x. But here you have positive 3 minus 5, that's -2. Again, you have a calculator to check that. You just do 3 minus 5. Boom, -2. And that is my slope-intercept form. So the slope is 1/8 and the intercept is -2. Over here, sorry, I'm going to put this in a little bubble so that it kind of is visually separated from my work. Again, the opposite here of plus 1 is minus 1. So if it was a negative here, you would do the opposite and add. But there, that goes away, that makes 0, and now y is alone. But again, you have to do the same thing on this side. Again, make sure you line it up. Neither of those have x's, so they go together. This has an x, so just leave it alone. Just be like, come on down here, 1/8 x. And then you have -1 minus 1. So remember, when you do this one in your calculator, make sure you use a negative for the negative part and a minus for the minus part. So you do -1 minus 1. And you can see on the calculator that the negatives are actually little smaller lines and up higher than those. So that should help you see if you've entered the right one. And you hit enter, and oh my gosh, wouldn't you know it, you get -2 as well. So, the big picture here is, how do you convert? You distribute, step 1. Get y alone, step 2. That's it. Should be super simple. The bigger picture here is, notice, no matter which point I picked from the problem, I got the same answer. So if Jessica does this one, she'll get y equals 1/8 x minus 2, and if Benjamin does this one, he'll get y equals 1/8 x minus 2. You'll get the same thing. And if you were to do it from like points on a line, any point on the line you pick, as long as you do it correctly, everyone will get the same answer, which is really, really cool. That's the hidden message. Okay? So, very cool. No matter what, you get the same thing. And in fact, I'm going to make a note and say they are the same. Put a little puffy cloud around it. Don't get any points unless you write this in your notes. They're the same. Haha, don't tell the other people that didn't watch the video. Okay, that's it. Again, a lot of info, nice and condensed on one little page. All right, I will see you guys in class, and let me know if you got questions. Bye!